Hey everyone, and welcome to today's Explainer. We're doing something a little bit different for you grade 7 learners today. We are going on a global safari. But, instead of tracking lions across the savannah or searching for elephants, we're actually going to observe human populations. We're going to look at our own species with the exact same awe and wonder you'd feel watching a massive, big-budget wildlife documentary. It's all about exploring humanity as this living, breathing, and constantly shifting global ecosystem.
Okay, just wrap your head around this number for a second. Over 8,237,000,000 people. That is the sheer, mind-bending scale of our entire human species sharing planet Earth right now, as of April 2025. Every single day, the human herd grows a little larger. And today, we're going to figure out exactly how the math behind this crazy planetary expansion actually works. Here is our map for today's journey. We'll start with our global human ecosystem, then dive into the forces of population growth. After that, we'll track South Africa's unique population journey, check out something called the bathtub effect, and wrap up by comparing a few different global habitats. All right, let's jump right into part 1, our global human ecosystem.
So think of this as our very first observation point out in the wild. Every ecosystem has inputs and outputs. For us, the inputs are the births. We're talking over 2 million babies born today alone, and well over 76 million so far this year. Now, the outputs, the deaths, are sitting at just under 29,000 today and almost 36 million this year. When you put those facts side by side, a pretty clear story emerges, right? Because the birth rate is just completely dwarfing the death rate, we're seeing a massive healthy surge in global population. We are adding far, far more people to the planet than we're losing.
But where is everybody actually living? It's not evenly spread out at all. Some areas are incredibly crowded, while others are surprisingly empty. India currently holds the top spot, with the absolute largest population on Earth, closely followed by China. But if we zoom our lens in a bit closer to home, as of April 2025, South Africa sits firmly at the 24th spot globally, with a vibrant, growing population of about 64.5 million people.
Moving on to part 2. The forces of population growth.
Now, you're definitely going to want to remember these next few terms. They are essential survival tools for your exams. Let's start with the most vital force of all, the birth rate. This represents the starting point of life in our ecosystem. The birth rate is simply defined as the number of babies born in a year for every 1,000 people in a country. You can kind of think of a high birth rate as a powerful engine directly driving a population upward. The higher this number, the faster the population expands.
Then, on the flip side of that coin, we have the death rate. You guessed it, that's the number of deaths in a country per 1,000 people in 1 year. So why does this matter so much? Well, a low death rate usually means you got a thriving, healthy habitat. People have access to good food, good medicine, and they're living longer. But a high death rate, that's a glaring warning sign. It tells us a country might be really struggling with things like healthcare, disease, or just poor living conditions. So what happens when we bring those two forces together? We get our third key term, population growth rate. This is basically the difference between the birth rate and the death rate. It's the ultimate momentum gauge for a nation. If births outpace deaths, boom, positive growth rate. But if deaths overtake births, the rate goes negative. And yes, that means the population is actually shrinking.
Okay, real talk for a second. If you are taking notes, grab a highlighter and mark this down immediately. This is your core exam formula. Birth rate minus death rate equals population growth rate. Lock it in right now. You are absolutely going to need to know this to calculate how fast any given country is growing or shrinking on your test.
Let's see this in action in part 3, South Africa's population journey. If we track South Africa's history, it's pretty fascinating. Back in 1980, the population was 29.5 million. Just a few years later, around 1983 and 1984, the population growth rate hit its absolute peak. But right after 1984, a steady decline in that growth rate kicks in. Even with that slower rate, though, by 1990, the total population had still climbed all the way to 40.7 million. Then, as we move closer to the present, there's a really stark anomaly in 2020. That marks the lowest population growth rate in modern history, a sudden, drastic drop caused directly by the COVID-19 pandemic.
Let's pause and actually do the math on that 1980 to 1990 jump. If you take the population in 1990 and subtract 1980, you get this massive 8-digit number, over 11 million people. That's exactly how many people were added to South Africa's population in just one single decade. Over 11 million new lives added to the ecosystem in 10 years. That is the sheer awe-inspiring power of a high birth rate in the wild.
All right, let's switch gears for part 4, the bathtub effect.
Up until now, we've only really talked about births and deaths. But populations also change because, well, humans love to move around. To visualize this, I want you to imagine a country is literally a giant bathtub. The water sitting inside the tub, that represents the total population. On the left side, you've got your inputs acting like a running tap filling it up. These are the births plus immigrants. Immigrants are people moving permanently into the country. Then, on the right side, you've got your outputs acting like the drain letting water out. These are deaths and emigrants. Emigrants are people packing up and moving out of the country. So population growth isn't just about who's born and who dies. It is a continuous, dynamic balancing act between the flow of people coming in and the flow of people going out.
And finally, part 5, comparing global habitats. It's time to step back and apply all these awesome concepts to some totally different global environments. Let's look at 6 entirely different habitats. Just marvel at Mozambique for a second, a staggering birth rate of 40. Compare that to Japan, with a birth rate of just 7. Now check out the death rates. Brazil boasts an impressively low death rate of just 6, which points to a super healthy population, while South Africa's sits at 17. By applying our trusty exam formula, birth rate minus death rate, we get the population growth rate. Ghana sits at 19, South Africa at 2, and France at a very modest 3. When you map out those growth rates we just calculated, the extremes of our global ecosystem become crystal clear. Mozambique is towering way up there at 27. They are expanding incredibly rapidly. Brazil is cruising in the middle with a steady, healthy growth rate of 12. But wait, check out Japan. They are at -2. Because their death rate of 9 is actually higher than their birth rate of 7, Japan's population isn't just growing slowly, it is literally shrinking in real time. No way, right?
Which leaves us with a huge, real-world dynamic to ponder. When you have a population growing as fast as Mozambique's, what happens when that habitat simply cannot create enough jobs, housing, or resources for everyone? Understanding the math behind human geography isn't just about passing an exam. It's about understanding the very real challenges our species faces in the wild. Keep that provocative thought in mind as you study. Thanks so much for joining me on this incredible global safari, and good luck conquering your exams.